says toy animals are sold in sets of 3, 5, 10, and 12. Mason wants to make a display with 3 animals in each row. Mason can only buy one set. Which sets could he buy if he wants to display all of the animals? There's 2 different ways that we could approach this problem, but regardless of which way we choose, we really have to understand the difference between factors and multiples. Factors and multiples are related, but they're different. So if we look at this example here, 3 times 4 equals 12, my factors in this problem are 3 and 4. 12 is a multiple of both 3 and 4. So when we start to solve this problem, one way that we could solve is to find factors. Since I want to know which set to buy, and I know that I want to put 3 on a shelf, I know that the set that I choose to buy, either a set of 3, 5, 10, or 12, that 3 needs to be a factor of that number. So I'm going to take my different set totals over here. So I know that we could do a set of 3, a set of 5, a set of 10, or a set of 12. And I'm going to ask myself, is 3 a factor of 3? And I know it is because 3 times 1 equals 3. Or I could think, is 3 divisible by 3? And yes, I could say, yes, it's divisible. I'm going to abbreviate that with div by 3, right? Now I'm going to think of this set of 5. Is 5 divisible by 3? No, it's not. So no, not divisible by 3. I'm going to keep going. What about 10? Is 10 divisible by 3? And we know the answer to that is no, it's not divisible by 3. Well, what about our last option? Our last option is a set of 12. Is 12 divisible by 3? And we know that it is, yes. 12 is divisible by 3, and we know that we would get 4, right? If we divided by 12 by 3, we would get 4. So this, using factors, is helping us to realize that we could purchase either a set of 3 or we could purchase a set of 12 and be able to display our animals with 3 in a row. Remember, if it's challenging for us to think of these factors, we could use manipulatives or draw an array, just like we did with the bugs in a previous lesson for this chapter. Another way to solve this problem is to think of multiples, to find multiples. We can make a list by multiplying. So let's start with 1 times 3. We know that's 3. The next multiple of 3, we know 2 times 3 would be 6. 3 times 3 is 9. 4 times 3, which is the same as 3 times 4 because of our commutative property, you know that, is 12. 5 times 3 is 15. And I'm going to stop there because the largest number that I see here as other options is 12. So we're good to go here. Now I'm going to look at my multiples, and I see that both 3 and 12, which are options for our sets, are multiples of 3. I don't see 5 or 10 anywhere on this list here as a multiple of 3, so I know those are not options. So looking at both are using the factor strategy to think through, is 3 a factor of this total set, or is finding our multiples, thinking through our multiples of our basic number that we're looking for. So either strategy here, you find that you have the same answer. Either a set of 3 or a set of 12 will allow Mason to display all of his animals with 3 in a row. Remember, while both of these factors and multiples are great strategies to use, it's important to understand the difference. Multiples are the product of a multiplication sentence, and our factors are the 2 numbers that we're multiplying together.